video series. Last week I said we were probably going to be done with our functional programming stuff. I've had a wee bit of a change of heart after today, actually. I thought I'd reached a level of understanding with these functions that I didn't feel the need to go into the standard library functions. And that was selling functional programming short because I was trying to come up with, simple examples and academic examples of how to use things like, map and reduce and lambda. And during the day I've had today while I was teaching students this week, I've been teaching them about classes in JavaScript. One particular student came to me and said they didn't get JavaScript. That's fair. They come from a mathematical background. And so I had to go through some of the components of the lambda calculus, of course, from which Common Lisp derives. And we went through this and it made a lot more sense. And I went away to the gym, I came back, and then something hit me. And although Common Lisp has an object system, it's got class, of course, it is possible to build something that is arguably an object system. It's not going to be a great one. It's not particularly elegant. I'm not advocating that everybody go away and write their own object system or even use what I'm going to build here. But I had success with a couple of students who understood functions but couldn't make the jump between functions and object orientation. And I came up with something I'm going to demonstrate here. So this is a perfect example of some parts of functional programming, and as the story goes, Lisp was used to create some of the earliest object-oriented programming. I believe Smalltalk, Alan Kay built it in a version of Lisp. So we are going to have a wee go here and build our own object system using nothing but functions. So we're going to create a person, and they take a name and an age, and it's going to return a lambda function which takes a parameter called property. And we're going to do a cond. I'm going to say string equals property. Say name. I'm going to return name. Same here, we're going to say string property. Age. We're going to compile that in. And I'm going to create a little let here. P is person. Gary, he's going to be 24. And we're going to say apply P. Oh, actually, print apply P name. Print apply P age. And then we've got Gary and 24. So we now have this function that is using a closure. So we're having a function that returns a function, and that allows us to close over and capture these values, name and age. So that's pretty cool. We have this function that when called with particular parameters will get the value stored in this. So this arguably is accessor properties. We go to the object, this function, we say we want the name and it gives us the value, or we want the age and it gives us the value. However, this is pretty ugly. So we're going to write a convenience method for it. So now we're going to say get property. I need to compile this, of course. And that is apply object, not P. go. So I'm going to make sure that's compiled in. We've redefined that. We've got no more spirit variable. Great. So if I run this now, we get Gary and 24. So this is much nicer. We're only using this apply in one place now. I'm going to use that backtick and comma stuff to get that. So we now have this general get property function, but we can do better. There we go. And this now becomes get name p, get age p. So if I compile these in, so now we've got these accessor methods for get name and get age. My goodness, this heat wave and the pollen, it's really bad for my allergies, but never mind, we will persevere. So this is really not a lot of code for what we've managed to achieve here. We're closing over a function and we're storing these properties in that function, and we can use accessor methods that we've created here, and they get the values stored in that function, which is super cool. But this is only half an object system. It's like a read-only object system. After the object's been created, we cannot change these values. And that's unfortunate, but it is what it is. But we can work around this. So we're going to get the property. So what we are going to do, I think, is we're going to use another cond here. String equals property name. We're going to say person, and we're passing name. Property is name, and we're passing property. Sorry, of course. That was a very simple mistake for me to make there. That's going to be fine. I need to compile that in, of course. So property, and we're going to compile the object gets passed through. I'm going to pass in name and value. I'm going to do the same for set age. Now the thing is here, we're not actually changing the actual object. What we're doing is we're returning a new object with modified values. This is where you get like immutable objects. So even in object-oriented languages like Java and Python, certain types of object, like strings, they are immutable. You cannot change them, and any operation that looks like it modifies a string behind the scenes actually just creates you a new string. So fundamentally speaking, if those are still treated as objects, if we have this idea of returning a new instance of an object when it changes, that's not exactly cheating. That is perfectly fair and other languages do it. So with that in mind, we could say setf p, and that's going to be set name, and this is going to be Bob. And we're going to set his, we're going to do that again, setf p, set age 20, we'll make him 18. And we'll copy these two lines. So now when we run this code, we have an error, set name is undefined. Of course I should compile that in if I hadn't already, so let's retry that. That's 4. Invalid number of arguments. Of course that needs to be p, of course. So let's abort that and just restart that. Set age is undefined, alright. Sorry, I didn't notice that, so I'll have to redefine that one. There we go. Let's retry. There we go. A couple of errors, you know, stupid little things. But we can see here now in the right-hand side, we say Gary is 24, and then we say Bob is 18. So let's format this just a little bit better. And we'll get rid of those two. Save that, and we'll do that so we get yeah, okay, so that's just left over because I didn't have the print line. So let's now the new line, there we go. I'll just clear that and we'll print that again. So Gary is 24, Bob is 18. We are able to set f our object here with the new values. It's a two-step process. Not the most efficient in the world. Of course, this is not a real object system. It is just a demonstration. But we can see here that all of the basic building blocks of an object-oriented system are here. It's a wonderful revelation to look and see that all of this was possible because of a lambda, and I struggled to find examples just the other week, and I think this is an incredibly powerful thing here. I have a function that returns a function, and honestly the lambda calculus is just amazing. I admit I don't understand nearly as well as I ought to, but this, I was blown away at just how simple this was. I scared myself. Genuinely, I did. But there we go. I am surprised that I was able to talk about this in less than 15 minutes. So, small sort of slushy video today, you know, looking at something unique, something a little bit different. I will be trying to teach this in the courses that I develop going forward. But I'm wondering if we can make this I'm wondering if we can expand on this in some way, shape or form. How I'm going to do that, I'm not sure. We might not come back to this. I am not entirely sure what video is coming up next week. I think maybe we will look at setting up a project and packages, because they were very mystifying to me when I first got started. It's only through experience and playing with them and trial and error that eventually it's all clicked into place. So I think that would be a very useful video for next week. But apologies for this being shorter than usual, but I hope it has been interesting. Take care of yourselves. I will see you in the next video.